Okay, I'm here at the beach. I just want to, this is down in the west coast of Florida. My family and I did a trip down here in the springtime. And I just want to point out, and this is Siesta Key area, point out the weather that affects, they call it diurnally, every day you see these effects here. We started out the day with some showery skies, and then now as the wind is picking up off the ocean, it's kind of pushing the showers inland. I'll show you the pictures of what it looks like inland in a second. But I'm going to switch the camera here and we'll take a look at how the wind is blowing now versus what it was doing earlier. Okay, this is the wind direction now. This flag you're looking at is blowing basically from this side of the picture, which is the ocean side, to inland, that area, and it's blowing onshore. In other words, the wind is coming from off the Gulf of Mexico into the inland areas. If you look at the sky picture here, we see some clouds kind of billowing over inland areas, just inland from the coast, and then we kind of circle back and look offshore, and it's lots of blue sky, right? Now, this day in particular started out with cloudy skies and showers, but as the wind picked up from offshore and pushed the cloudiness inland, that kind of dispersed those showers we've had. We call it diurnal effect of the sea breeze taking place here as well. As the wind starts to come in off the Gulf in this case, the air is cooler over the water. It gets warmer over the land areas. So as the cool air sinks and the warm air inland rises, we get these little mini circulations forming. So the cool surface air blows inland, and that's why we're seeing this flag blow like this. And then as that air moves inland, we're seeing the rising air currents, and that's producing these what I would call billowing or building cumulus clouds just over inland areas this afternoon. Right now it's about 2 o'clock in the afternoon as I'm taping this. Okay, I'm now going to be walking down toward the water here from my vantage point that you just looked at. And the breeze is picking up a little bit. The closer I get to the water, the stronger the wind is. And that would be expected, of course, because not only that sea breeze, but also because of the frictional effects of the water versus the land. Over water, there's very little friction. So the air moves over the water into coastal areas, and because there's less friction, it doesn't slow down as much. Once it moves inland, it slows down, and we don't see nearly as breezy conditions, not that far inland either. So here I am walking toward coastal areas. You can see not quite a few people out here. It's kind of cool. This is early March now as I'm recording this. But water's not bad either. It's just interesting to note that the sea breeze, even on a quiet day like this, does take hold, even in the early springtime hours, during the early afternoon and late afternoon hours. All right, here I am at the edge of the water, and again, looking inland, we're seeing the building cumulus clouds, partly because of that sea breeze effect. As the wind goes inland, it rises, and we get these bubbles of building cumulus clouds. Another feature I notice, and you've noticed this if you've ever been to the beach, I'm only now, I don't know, maybe 100 yards from the water, and it was so much cooler down there than it is right here where I'm standing now, only about 100 yards. So again, there's another kind of atmospheric effect we're talking about, is the fact that the air gets cooled over the water, and that cooled air is what's coming in off the coast, off the shoreline. But then you get in just a little bit, and the wind diminishes, and you're getting more of the heat building from the sand and such here at the beach. Okay, as I'm walking closer to the, away from the water, closer to the inland area where the beach ends, it has gotten substantially hotter, just in this short, tiny little distance. And again, the sand is reflecting a lot of the light, of course, but it is helping to heat up the air versus what we saw right at the coastline. All right, now I'm well inland. I'm walking toward the main road where I came from. The buildings, you know, there's the moderate high-rise buildings here, nothing like you'd see in East Florida down toward Miami, that area, but they're built for the most part to withstand hurricane force conditions. And I think most of these buildings would survive just fine in a hurricane. What we're looking at, fairly low foliage. See, the palm trees here are not extremely high, so you're not looking at a lot of tree damage. even with a hurricane, but you will be looking at potentially power outages, that sort of thing, windows blown out, that kind of situation in an intense storm making landfall. And I'll talk more about the probabilities of landfalling storms here on the west coast of Florida, specifically Tampa Bay area, down towards Sarasota, that area, which is generally less vulnerable because of the way it's configured versus the Gulf of Mexico. Most storms kind of track to the south part of Florida, but to kind of flip back up into the Gulf Coast and make a direct impact is a little less likely, although it does happen, of course. And I'll talk more about that in another video module. So that's it. That's my little quick tour of the beach area here, Siesta Key, early March, early springtime, or actually technically not even spring yet. But we talked about the sea breeze effect, how that, this is the afternoon, how you really start to feel it in the afternoon. We talked about the cloud buildup because of that, onshore wind flow in the afternoon. And the fact that, you know, little microclimates do develop near the coastal areas. It's much warmer here inland versus way back where I was on the water. And it's only a few hundred yards away. So big differences in short distances on coastal areas because of, again, the sea breeze effects and the effects of topography and buildings and all of that sort of stuff.